Hello again. Again, I am Robin from the Boonshoff Museum at Discovery. Thanks for coming today. So last time we talked about matter, and we talked about our three states of matter: solids, which keep their shape and you can pick up; liquids, which flow and pour and take the shape of the bottom of the container they're in; and gases. Gases like to expand and fill up the space they're in. So we're going to use that knowledge and we're going to apply it to some really fun stuff that you can do at home with the help of an adult. So first things first, I want to make sure that you are safe. So in order to do these experiments, you will need some safety gear. I've got my handy dandy safety goggles. Now I realize you probably don't have safety goggles at home. So in a pinch, sunglasses work, or if you wear glasses, that works as well. All right, I'm going to go ahead and put mine on. All right, now in front of me, I've got a couple different materials. I've got some lovely vinegar inside a beaker. Yours does not need to be in a beaker. A cup is fine. I've added just a little bit of red food coloring as well as 1 drop of dish soap. The dish soap is totally optional. Now we also have some Play-Doh. It's covered in baking soda, which is that white powder inside. Now let's go over the states of matter. This vinegar, it takes the shape of the bottom of the container it's in. It flows, it pours. You can see it flowing and pouring as I pour it out of my little beaker. So indeed, we have a liquid. Now this little tiny volcano, the Play-Doh is a solid, right? And that baking soda is also a solid. Now it's hard to believe baking soda is a solid because it's so teeny, teeny, tiny, right? But I'm going to prove that it is indeed a solid by picking it up. It stays on my finger. And if I look really closely, it has a shape. Solids have a shape of their own, right? And they definitely don't flow and pour. So this little dude, that stuff there is indeed solid baking soda. Now, before I continue, I want to make sure that you have an adult with you at all times. Never do science by yourself and never eat or drink the science. Totally gross. Don't do it. All right, let's get started. So what's going to happen if I pour my stinky liquid vinegar into my baking soda? I'm going to give you guys just a second to ponder it. Make a guess, make a hypothesis. What's going to happen? Then go ahead and do it. Pour it on there. Oh, check it out. So immediately that vinegar and baking soda are having a reaction, which again is like a party. The chemicals are coming together and lots of gas bubbles are made. Now because we added that dish soap, it made it extra bubbly, which makes it pretty fun. Now say that you don't have Play-Doh at home, but you do have the baking soda and vinegar. What could you use to put your baking soda in? Well, in that case, you can use a cup. It could be this plastic cup like what we have. These are called like Dixie cups or things like that. Little tiny 3-ounce cups. You can use any general cup at home because this is pretty safe science and you can wash it out afterward. So we have half a tablespoon of baking soda in our cup. I did forget to mention I had a half a tablespoon of baking soda in the volcano as well. Really, whatever fills the bottom will work though. All right, now let's add some vinegar. Again, it's got some red food coloring and it's got a little bit of dish soap. Pour it in there. Whoa, that's so cool. I kind of like this one better, honestly, but I'll let you make your own opinion. It's going to keep reacting. Those bubbles are going to keep pouring over. Whoa, that was a big chunk. And I'm going to pop that big bubble because I can't resist. All right, so that's a pretty fun thing to do at home, but we can take this further. I'm going to go ahead and set this off to the side. Please forgive me as I step away. Now, to do the next experiment, you need a couple different things. You need a Ziploc bag. So I've got a Ziploc bag here. You need a paper towel or a tissue, and you also need baking soda, a tablespoon measuring device, and some stinky vinegar, and a half a cup to measure it in. So what are we going to do? Well, here at the Boonshoff, we like to make things extreme. So I've got a snack size Ziploc bag, I've got a sandwich-sized Ziploc bag, and I've got a gallon-sized Ziploc bag. And my thought is, what's gonna happen if we add baking soda and vinegar inside of these bags and then seal them up? So think for a second, ponder. You guys learned a lot from that last experiment. When we added that vinegar to the baking soda, it made a whole lot of gas. We saw all those gas bubbles coming out, but what would happen if we trapped it all inside a sealed bag? And like I said, we like to make things big here, so we've got lots of bags. Do you need all those bags? No, one will work just fine. So how do you do this? First things first, you want to take that paper towel. You want to lay it out nice and flat. And then we're going to add 1 tablespoon of baking soda. Just plop it right there in the middle. I'm going to set that off to the side. Now I'm going to fold it. If you don't like folding and you're too excited, bunching it up will work just fine too. All right, so now I've got this little packet. I'm going to place it into my large gallon-sized bag. All right, now next thing I need vinegar. So I've got a 1/2 cup of measuring device here, and then I've got my vinegar. I'm going to pour my vinegar into my cup, and then I'm going to add my already poured other cups to the experiment. All right, let's see what happens. This is going to be fun. I'm going to go ahead and start with the big one because I can pretty much guess it's going to take a little bit longer. I'm going to dump it in, seal it up really well. You might need an adult to seal the bag for you. I'm going to add my second one into my sandwich-sized bag, seal that one up, and then my little tiny snack-sized bag, and seal that up. Now, it helps to shake them up a little bit. And a big tip, you want to have the seal pointed up, and you also, with the gallon-sized bag, need to kind of angle it so that that vinegar can interact with the baking soda. All right, so already I see some really cool things. I hear bubbles. Not sure if you guys can hear that, but I hear a lot of bubbles. I see bubbles, and I see something else really cool happening. My bags are expanding, just like gas does, right? This one, the snack size bag, is really expanded. I'm a little nervous. So all 3 can stand by themselves now. All 3 have that cool reaction going on. And all 3, oh dear, all 3 are filling up with gas. So the bag is expanding because of all that carbon dioxide being produced. This is not good. What's going to happen? Ah! I'm glad I had my glasses on. So there was so much gas in here that it popped the bag. How cool is that? So a couple things to think about. Lots of different Ziploc bags out there in the world, and they all have different seals to them. Some are stronger than others. So your bag might pop, it might not pop. Your bag might seal better, so it'll fill up with gas better. Just different things to think about when you are doing your experiment at home with an adult. Pretty cool, right? All right, so let's set these off to the side and let's move on to our last experiment. Now this one is going to be one that you probably can't do at home, but I will tell you the ingredients so that if you happen to have these materials, you can give it a shot. But really it's here to show you guys or demonstrate what can happen. So I've got a couple different ingredients here. I have baking soda, I have a snack size bag, I have a sandwich size bag, and I have a very special chemical here called ISMA, or fancy word calcium chloride, fancy words. Now this is also a solid. I can pick it up, it keeps its shape. It's hard to change its shape. And what calcium chloride does is it melts snow and ice. So the Boonshoff Museum of Discovery, we're located in Dayton, Ohio, and we get quite a bit of snow and ice. So we will see this on the roads and sidewalks, working that wonderful job of melting that snow and ice. It's pretty cool stuff. So what are we gonna do with this? Well, we're gonna add 1 tablespoon of each chemical to the bags. So we're gonna start with the snack size bag and the baking soda. So 1 tablespoon of baking soda into the snack size bag. And then into the sandwich size bag, we are going to add 1 tablespoon of calcium chloride or ice melt. All right, that's not very exciting, is it? I promised you super cool science here. So again, we've got 2 different solids. They're both white. They both have little tiny ball shapes to them. They're pretty cool. Now to that, we're gonna add our liquid. Our liquid is very simple, it's water. So any guesses what's gonna happen if we add our liquid water to our different chemicals here? Gonna give you a second to ponder that. Okay. We don't have to be precise here. We just wanna add enough liquid water to each chemical to make it kind of wet, all right? So I'm gonna go ahead and pour some liquid into my baking soda. I'm gonna seal it up just so it doesn't spill. And I'm gonna show you guys something here. This is pretty cool. We've got a good old telephone here with a thermal camera on it. And that thermal camera, if I position it in front of the bag, there, I think you guys can see it. It's picking up the temperature. So right now, you can see me kind of squishing it with my hand. The bag is really blue, and it's got a temperature there, and it says around 72 degrees Fahrenheit. All right, that's pretty cool. All right, I'm gonna place that off to the side. Now, let's see if it's any different with the ice melt or the calcium chloride. Again, I'm just gonna add enough liquid to get it wet. I'm gonna seal it up so it doesn't spill. Now, let's compare things. Whoa, can't wait to show you guys this. Check it out. Wow, it's super, super red. That means it's really, really warm. It's releasing a lot of heat energy, which is called an exothermic reaction. Right now it's at 161 degrees Fahrenheit. Oh, it just jumped, it's kind of dancing around. So it's jumping between 165 and 161 degrees Fahrenheit. That's pretty cool, right? Calcium chloride in the water, that's an exothermic reaction. So it's releasing heat. In this endothermic reaction, the heat is being taken from the area around it. Pretty cool, right? Now this is pretty neat science, but it gets even cooler. So let's see what happens if we mix them together. Again, if you are able to do this at home, if you happen to have ice melt, please do this with safety glasses and with an adult's assistance. Now what I'm going to do is I'm going to dump my baking soda and water in with the ice melt and water. Now to do that, I'm going to flip it upside down. I'm going to throw my baking soda bag in there, and I'm going to seal the bag up. Now immediately there are a ton of gas bubbles happening. The bag is filling up, and it makes me yelp. So it's filling up with gas. Again, that gas expands, fills up the space it's in. This is pretty cool. Now what you guys can't hear, lots of gas bubbles popping, and it's still pretty warm. Pretty neat stuff. Very cool science. I hope you guys have enjoyed the science that we have done today. Please hit the like button if you enjoyed the show, as well as subscribe to our YouTube channel. Thank you. Have a good day.